question 14. So part A, show that the equation 2 tan theta times by 8 cos theta plus 23 sin square theta equal to 8 sin 2 theta times 1 plus tan square theta may be written as this form. Okay, let's get started. So 2 tan theta times 8 cos theta plus 23 sin square theta equal to 8 sin 2 theta times 1 plus tan square theta. So first I can change 1 plus tan square theta into sec square theta. So using the identity straight away. So 2 tan theta, 8 cos theta plus 23 sin square theta stay the same, and it equal to 8 sin 2 theta times by sec square theta. And then because in the final expression it's just sine and cos left, so no tan, no sec. So I'm going to change tan theta into sin theta over cos theta, and then 8 cos theta plus 23 times by sin square theta. So sin square theta equal to 1 minus cos square theta, and that's equal to 8 sin 2 theta times by 1 over cos square theta. And then times by cos square theta for both sides. So then that would be 2 sin theta cos theta. Because if we times by cos square theta for both sides, then those two cancel out. And then cos square theta over cos theta, just cos theta left. So that would be 2 sin theta cos theta. And then in brackets, 8 cos theta plus 23 minus 23 cos square theta. And then equal to 8 sin 2 theta. And then 2 sin theta cos theta, that's just sin 2 theta. And then 8 cos theta, actually, let me just write it in order. So negative 23 cos square theta plus 8 cos theta plus 23. And then our minus 8 sin 2 theta for both sides equal to 0. So now we have sin 2 theta as the common factor. So what we can factorize out sin 2 theta. So that would be negative 23 cos square theta plus 8 cos theta, and then plus 23 minus 8 equal to 0. So then sin 2 theta negative 23 cos square theta plus 8 cos theta, and then plus 15 equal to 0. So I think this is fine, but I normally keep the coefficient of the highest power positive. So I'm going to times by -1 for both sides to make it 23 cos square theta minus 8 cos theta minus 15 equal to 0. That's a final answer. And then part B, please solve for x between 360 and 540. So this equation, yeah, that's exactly the same as the part A. The only difference is instead of theta, this is x. Instead of theta is x. So that all the rest will be exactly the same. So we can just use the result we get from before. So that would be sine 2x and then 23 cos square x minus 8 cos x minus 15 equal to 0. So then that means sine 2x is equal to 0, or 23 cos square x minus 8 cos x minus 15 equal to 0. So if x is between 360 and 540, that means 2x should be in between 720 and then 1080. So if 2x equal to 0, so I mean sine 2x equal to 0, then 2x has to be 0, 180, 360, 540, and then 720, and then plus another 180, 900, and then plus another 180, which is 1080. So that would be all the values between, so the values between 720 and 1080 would be those three. Then divide by 2, so we have 360, 450, and then 540 if we divide by 2. And because it says x cannot be 450, so ignore this one. So x has to be 360 or 540. So we have two solutions now. So now we just have to solve the second one. So put into the calculator 23, -8, and -15. So we have cos x equal to 1 or cos x equal to -15 over 23. So if cos x is equal to 1, x is either 0 or 360 or 720. So just keep plus 760. But x can only in between 760 and 540. So ignore this and ignore this. So 760 will be one of the solution for this one. And we already have 760. So but let's just keep it here. And then x for the second one, cos inverse of -15 over 23. So that would be 130.7. And then the other solution would be 360 minus that. So that would be 229.3. And then plus 360 for both of them, 130.7 plus 160, that would be 490.7. And then 229.3 plus 160, that would be 589.3. So outside interval, outside interval, outside interval. So only 490.7 inside interval. So the final answer to this question will be x is equal to 360, 540, and then 490.7 degrees. So three solutions in total.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.